I would say, advanced techniques when integrating by parts. And I will show you two examples where you can use those techniques. Well, at this point, if you're watching this video, I assume that you are feeling more or less confident with basic integration by parts. And if you're not feeling confident, please have a look at the first two parts of my videos. Okay, so the first example is going to be 1 over x, of course, the integral, times natural log x dx. Okay, so it looks like we have two functions multiplied together, and the two functions are of a different type. So that means we can possibly use integration by parts. So let's state the formula. The integral of u derivative v equals to uv minus the integral, and then we switch the derivative. So u times v derivative. And at this point, let's choose which one is going to be u derivative and which one is going to be v. Okay, now I will choose 1 over x to be u derivative, and v is going to be natural log x. So that means I will have to integrate 1 over x to get u, and we know that this is going to be natural log x, and v derivative is going to be 1 over x. And let's rewrite the original integral. So that is going to be u times v, so log x times log x, which is log x squared, minus the integral of v derivative, 1 over x, times u log x dx. But hold on, it looks like we have seen this integral before, didn't we? That's actually our original problem. So we can say that the integral of 1 over x log x dx equals to log x squared minus the integral of 1 over x natural log x dx. And now we can rearrange this equation and move the integrals to the left side. So we'll get 2 times the integral of 1 over x natural log x dx equals to log x squared. And we divide by 2 both sides of the equation. To get the answer for this question. So that is one more technique which you can possibly use while integrating by parts. And let's move on to the second question. So for the next one, I decided to integrate the exponential function e to the power of x, and then a trigonometric one, so sine x dx. Let's take the formula. Integral of u derivative v equals to u times v minus the integral of v derivative times u. And let's choose which one is going to be u derivative and which one is going to be v. I will choose sine x to be u derivative, so it's sine x, and v has to be e to the power of x. That means u is going to be the integral of sine x, which is minus cosine x, and v derivative is e to the power of x. And now at this point, let's rewrite our original integral as u times v, so minus e to the power of x times cosine x minus the integral of v derivative times u. So it's minus e to the power of x cosine x dx. Let's simplify a little bit further. Minus and minus will be plus, so integral of e to the power of x cosine x dx. Now that looks very similar to our original question, apart from the fact that we have cosine x instead of sine x. Let's try to deal with the integral separately. So we're trying to integrate e to the power of x times cosine x dx. Again, we've got two different functions of a different type. One is exponential, and the other one is trigonometric, cosine x. So possibly we can use integration by parts. U derivative v equals to, okay, no derivative, minus the integral, and we switch the derivative. Let's choose which one is going to be u derivative and which one is going to be v. I will choose cosine x to be u derivative. And then e to the power of x has to be v. Now u is going to be the integral of cosine x, which is sine x. And the v derivative is going to be, again, e to the power of x. Now let's rewrite the original integral as u times v, so e to the power of x times sine x minus the integral of u times v derivative. So it's e to the power of x sine x dx. Now, have you seen this integral before? E to the power of x times sine x. Yes, that's the original integral. So let's rewrite the original question as the integral of e to the power of x sine x dx equals to, look at this line, that equals to minus e to the power of x cosine x and then we've got integral of e to the power of x cosine x dx, which, as we have seen before, equals to e to the power of x sine x minus the integral of e to the power of x sine x dx. Now I'm going to use a similar technique to what I've done in question 1, and I will collect all the integrals on the left side. So I will get 2 integral of e to the power of x sine x dx, and I will write the term with sine x first. So e to the power of x sine x minus the integral of e to the power of x cosine x. Now let's divide both sides by 2 and get the answer for our question. I will also factorize to make it look a bit better. Okay, so all of this divided by 2.